Okie dokie. Welcome to the notes portion of our lesson for today. And the topic that we're working on, we're still trying to factor. And we're really working on quadratics. So let's go ahead and begin to get used to that word. All right, trinomials. All right, so we're factoring quadratics. It's the same thing as factoring trinomials. All right, today's date is 2020, right? It's Monday. I think I have the wrong date. It's actually the 6th. I'm sorry. The objective is for us to be able to factor quadratics. And this time, we're going to be looking at some special cases. Okay, we're going to be looking at some special cases. So we're looking at some special cases. So we are able to factor quadratic, right? You guys already know to check for your A, your B, your C. You guys would go ahead and do your AC method and would factor. But sometimes when we have quadratics, we don't have to do all of that, especially if we can quickly figure out what we're looking at. So let's go ahead and look at the first example. It says a garden has area of y squared minus 16. Find the possible dimensions. Well, we know that it's an area, right? The possible dimensions. What are the possible dimensions? What I know about area is that is length times width, okay? That is length times width. So if I multiply my length times width, I should get my area. So let me go ahead and quickly sketch. I need my length, I need my width, and if I multiply length times width, I should get y squared minus 16. Okay, cool. So if I check, this is a quadratic, so I can go ahead and try to factor this guy. All right, so I need two factors. I need my length and I need my width. Okay, check if there's a GCF. There is none. Notice that the second step says check if we have perfect squares. The reason we ask for that is because if we have perfect squares, it simply means that we're not going to do the same thing. Notice that I don't have all the things, label your A, B, and C and all of that. Because especially when it's perfect squares, we treat them a little bit different because they're kind of special. Now, if you look close, what does it mean to be special? Really, it means that I have two perfect squares. Okay, we kind of talked about this last week. So my y is perfect. How do I know? It's y times y. 16 is perfect. If you remember, that is 4 times 4. So if I know that I have a perfect square at the beginning and a perfect square at the end, all I need to check next is the sign. It is a difference, right? So if it's a difference, we call it a difference of squares. If it's a difference of squares, then it makes my life so much easier. Okay, I have a square at the front, square at the back, and I'm subtracting them. All I need is a y here and a y here, because when I multiply them, it will give me y squared. We already figured out that 16 is 4 times 4, so I will have a 4 here and a 4 here. Sorry, we're multiplying. One of these guys need to be positive and the other one needs to be negative. Why? Because it's a difference of squares. Okay, it's a difference of squares. So again, let's go ahead and just quickly do our box method. Have y minus 4, y plus 4. Y times y, y squared minus 4y, plus 4y. And 4 times 4, negative 16. These two guys cancel out because it's a positive and negative 4. So I'll have y squared minus 16. Now, if you don't remember perfect squares, you can always go ahead as I said, and set this up. I have negative 16. You can always go ahead and set up your A, B, and C. My B term is missing, so I can make that a plus x, 0x. And then go ahead and do my A, my B, my C. You know, you can go ahead and do that. We'll have negative 16, 0. Two factors that will multiply and give me negative 16, but will add and give me 0. Well, that's positive and negative 4. Okay, so you can go ahead and do that, but that will take a very long time. If you know that I have a perfect square at the front and a perfect square at the back, my answer will look kind of something like this. And it's a difference of squares, so my signs will be different. All right, let's go ahead and look at some more examples, says we do. So again, look at the beginning. It's a nice perfect square, right? That's 25. It's nice and perfect. How do I know? Because that's 5 times 5. M is also perfect. M times M. 36 is perfect. 6 times 6. In the middle, I have a difference of squares, so I'm good to go, okay? So all I have to do is to set my factors up. I need a 5 at the front, 5 at the front, and M on this one, M on this one. A 6 in the back, 6 in the back. A difference of squares means different signs, okay? And this will only work because I have a subtraction. If, for example, I had this actually cannot be factored, okay? So that it won't work if it looks like that, okay? It will only work if I have a difference of perfect squares, all right? Difference of squares. All right, let's look at another one. Perfect, right? X times X at the front. Look at the back. I have 7 times 7 and Y times Y. So this is perfect all around. So here we go. There are no GCF. Nothing for me to factor out. Nothing in common, and it's perfect. So all I have to do, set up my factors. Need an X at the front, X at the back, 7 and Y's at the back. So I need 1 7 here, 1 here, a Y here, a Y here. Difference in the middle, signs are going to be different. Okay, good to go. I like this example because even though this example is here, notice that these guys are not perfect. All right, they're not perfect. Okay, so here, the first thing remember to always do is to check for a GCF. It looks kind of weird, but if I check for a GCF, let's see what happens. So 8 and 18, what do they have in common? Let's go ahead and set that up. Remember that I can actually pluck out a 2 because both my numbers ends with an 8. So I can actually pluck out a 2 and see what happens. So 2 goes into 8 4 times. And 2 goes into 18 9 times. All right. Look closer. All right. Can you see it? Can you actually see it? I think I see it. I'm a little bit excited because I saw it. Now I don't need to rearrange this or anything. I can't factor out anything else. This is it. But if I look closely, I see that I have 2 times 2 at the front. So that is perfect. 9 is 3 times 3. That is perfect. And y squared, that is y times y. That is perfect. So all I have to do is to set up my factors. I need a 2 at the front, 2 here. I need a 3 and a y at the back, a 3 and a y at the back, 3 and y. Difference of squares. So here, one of my signs must be positive, the other must be negative. So my sign must be different for a difference of squares. And I cannot forget my GCF. You know the question I always ask. Okay, this is my final answer. Now, how many factors do I have? Well, there are about 3 of them. 2 is a factor. Everything inside here is a factor, 2 plus 3y. and everything inside here is a factor. 2 minus 3y. Okay, so I have 3 factors here. All right, go ahead and practice on the other side. Try the you-dos.